dua lagi speaker yang akan memberi perkongsian. Nak tahu apa, tunggu esok. Okey, boleh dah daftar dulu, okey? Dapatkan CG tu. Dan CG tu yang biasa sebabkan gambar yang digunakan background tu adalah gambar daripada James Webb Space Telescope. Teleskop IR. Near infrared. Okay. So kita tunggu dulu daripada green light daripada technical team dan kita akan teruskanlah. So kita akan mulakan dengan ceramah daripada Profesor Madia, Prof Madia daripada Australia National University, ANU. Okay. Nanti dia dapat hadir sebabkan COVID, maka dia akan buat online lah. Jadi itulah kita tunggu sekarang ni untuk tengok dia online. Lepas dengar ceramah daripada perkongsian daripada Profesor Madia Yuan Senting, lepas tu kita akan buat cerapan. InsyaAllah. Doa-doakan semoga langit clear. Kita ada 3 teleskop yang standby untuk melihat bulan dan benda lain lah. So astronomers ni sedang hiding inside you guys. Ada astronomers tau sini. Cari siapa lah tu. Dia tengah ada sini ni sekarang. Ada 3 orang ni. Siapa? Tarikh lah. Okey, so kita tunggu dulu, okey? Untuk sesi perkongsian daripada Prof Yuan Sen. So sementara menunggu ni saya nak tunjuk sikit lah siapa saya ni kan, tiba-tiba bercakap depan. Saya adalah daripada Dark Sky Malaysia. Dark Sky Malaysia ni satu organisasi yang berjuang langit malam. Gitu. Kami taklah bawa perang. Kan? Kami ni membawa teleskop. Tapi apa kami buat adalah memperjuangkan langit malam dengan menjaga langit. Kami memberitahu orang ramai yang kita ni lagi-lagi di Sabah lah. Cantik betul langit. Tapi cuma kita nak tengok langit. Tengok begitu siap kan. Tapi yalah ada sejak lah begitulah. Bintang semua sama siap kan. Kan? Semua bentuk sama siap. Actually bintang ni macam manusia juga tau. Dia ada nama, dia ada behavior dia ada umur, dia ada colour. Lain bintang lain dia punya perangai. Bukannya semua yang baik-baik, semua ada yang nakal. Oh gitu. Habis aku kena marah dengan profesor nanti. Dia belakang tengok je tu. Okey, bintang ni itulah macam manusia jugalah. Dia nama ni. Dia bila bintang orang cakap kan bintang semua sama siap kan. Kecil hati dia tahu. Jadi bintang tidak sama. Okey. Sebab itulah kami di Dark Sky Malaysia ni kami membuat awareness tentang bintang, tentang langit supaya orang tengok langit dan tidak mencemarkan langit. Mencemarkan macam mana tu macam kita letak light bulb di luar, di pagar. Biasalah kan murah, begitu siap kan. Tapi sebenarnya benda tu membunuh bintang. Bintang mati bukan sebab dia tua. Habis kena marah lagi lepas ni. Dia mati sebab kita membunuh. Dengan menggunakan lampu. Lampu yang overkill begitu. Macam terlalu terang betul. Orang bilang macam, terang betul memanglah nanti biar binatang takut betul dengan lampu. Tak. Binatang takut sama api, bukan lampu. Jangan fikir begitulah. Lagi satu orang kata, nanti perompak, senang mau tengok perompak. Perompak lagi suka tu lampu tau. Sebab apa? Senang mau tengok. Kalau mau tahu ada perompak, pakai yang ada motion sensor. Itu boleh. Dia tahu, okey kalau kita gerak, dia menyala kan. Boleh, buat terkejut. Lari dia tu. Kan? So, kita kena buang perspektif yang ada lampu selamat. Tidak. Ada lampu tu kadang bahaya juga. Tapi kita pandai tau. Kata macam waktu maghrib kan, ada kekatu. Burung-burung kan yang suka di lampu kan. Pandai kita kasih off tu lampu. Kita tahu kalau dia tiada lampu, dia tidak datang. Jadi kita pandai off. So, tapi itulah, itu macam berlawan pula yang kita cakap binatang takut lampu. Binatang suka lampu. Okay. So saya dah tunjukkan, alamak dah pusing ni. Baru mau tunjuk ni video ni, langit-langit Sabah. Okay. Boleh start kah? Okay, bersemangat sudah ni ya. Oh, boleh start, saya sampai sudah pun. Inilah kita punya profesor. Hai.
Hello.
Hello.
Oh, okay. Hi. We are live online here.
I think I still hear my
echo.
Pardon?
So yeah, I can still hear myself.
Oh, echo. You can hear yourself.
Yeah. So maybe when I speak, you might need to mute. I think that might work.
I'm on my mic right now, so you can hear your voice with my mic.
Okay.
So maybe you can bear for a while. I'll off my mic later.
Okay.
Is it okay?
Yep.
All
Sure.
right.
Sure.
All right. Okay. Okay. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera pada semua. Selamat datang semua sekali lagi kepada di Galeri Azman Hashim. Okay. Jadi kita ada juga pengunjung fizikal dan juga pengunjung atas talian. Okay, selamat datang ke Global Malaysian Astronomers Convention 2023 Roadshow Sabah. Jadi perkongsian kita pada malam ini lebih kurang 25 minit dan kita akan ada 5 minit sesi soal jawab. Jadi kepada semua pengunjung kami mengharapkan anda semua boleh daftar dan dapatkan e-sijil di QR code. Saya ada pendaftaran di depan ataupun yang tadi tu saya tunjuk. Dan kepada yang online boleh di pautan bit.ly/gmac2023 Sabah. Okey. Maka malam ni, specialnya malam ni kita akan bersama Prof. Madya Yuan Senting dari Astrophysics and Computer Science, Australian National University. Untuk makluman semua kan, pada tahun 2018, beliau pernah dianugerahkan NASA Hubble Fellowship dan beliau pernah berkongsi di TED Talk secara antarabangsa. Okey, untuk sesi malam ni beliau akan bercakap dalam bahasa Inggeris. Kalau ada apa-apa soalan boleh tujukan semasa sesi soal jawab ataupun boleh masukkan dalam kami punya Facebook dan YouTube dan tanya di situ. Okey? Dan kami akan cuba jawab di akhir sesi nanti. Jadi tanpa membuang masa, kita menjemput Prof. Madya Yuan Senting dengan tajuknya Early Disk Galaxy Formation from James Webb Space Telescope to the Milky Way. So let's give a round of applause to Associate Professor Yuan Senting. All yours.
Okay, I will share my screen. Okay, let's see. Can you see my screen? I think that's okay, right? Do you see my screen?
Teknikal boleh masukkan skrin?
Is it working? Oh, okay. Yeah, I think you see my screen. Okay, wonderful. Okay, good evening, everybody. So as Emma said, because my Malay is not as fluent as it used to be, so I think I will switch to English. But of course, you can ask your question in Malay, and it should be fine. Okay, so thank you, Emma, for a very kind introduction. And today I thought I want to talk about James Webb, because of course James Webb has been a very exciting topic in the last few years. So for people who do not know, James Webb is this huge telescope that we just flown to the space last year. So it's the largest space telescope that we have flown to the space. The machine costs about $10 billion in US dollar, and it's so big that we need to like fold that into with a origami technique, fold that so that we can fit into a rocket, flew that into the space, and then unfold it with the origami like technique. So I want to talk about like today what we have found with James Webb. So this is of course a very like cutting edge science, and talk about why like James Webb, like even in the first few months, has really started to causes like a loss of trouble for astronomers, because as you can see from this the article in Nature, like within a few months, like the astronomer has started to like panic a little bit, because like even the first few months of James Webb has uncovered some of the things that we did not like expect, and this is mostly in the context of what we call like galaxy evolution, which is it forces us to evaluate like our understanding on how the galaxy like evolve, which is something that I want to talk to you about. And I also chose this topic because, as you might know, we have so after Gmac, so like Gmac is our big like Malaysian like astronomy conference, but upcoming in the next 2 weeks, we also have a international like conference in Malaysia, in Kuala Lumpur, focusing on this like dilemma and panic that we are like facing now. So in that like conference that will happen in a week time, we try to understand sort of like using James Webb to understand like galaxy evolution. So if you are interested, you can go to jwstmalaysia.com and have a look at the program. But more importantly, of course, this talk will be more technical. But for the publics, we also have a public a special like a public a session at in Kuala Lumpur. I know it's very far from where you live, but the important point is that like this talk will all be like public like after the event. So we will have 3 experts to talk about, again, like James Webb and also galaxy evolution on the February of 8th. So if you happen to be in KL, please come to us. But if not, like you can also go to jwstmalaysia.com after the event to look at the recording. So let me walk you through a little bit of context. What is this like panic, and what's this like new discovery that we found from James Webb? But in order to explain that, I need to give you some context, like what we are talking about. So I want to explain to you a little bit about the brief like history of the universe. So here, what is shown here is a very brief history of the universe. On the left-hand side here is the Big Bang. So like this is where the universe starts, and of course on the right-hand side is where we are at like today. So we are at about 13.8 like billion years after the Big Bang. First, like you might ask, hey, why do we know like Big Bang is real? Oh, yeah, also I mentioned that of course, Emma mentioned I would really love to join you guys in person. I have planned for this trip for many months. Unfortunately, I got COVID like last week, so I'm still like recovering. So if I cough like during the talk, I'm sorry for that. So anyway, so we started with a Big Bang. So how do we know the Big Bang is real? One of the strongest clue to why the Big Bang has happened is the following. So when the Big Bang first happened, it's kind of like you go into a very cramped LRT like station, right? So when the universe first started, the universe is extremely small. And when the universe is extremely small, then the universe is extremely hot, just like a very packed LRT like station, right? When the universe is very hot, most of the proton they cannot bound to the electron. So we have a soup of protons and electron, and this is basically a plasma. So what is a plasma? So if you go look at your your TV screen, inside your TV screen is a plasma. But as the universe expanded, the temperature of the universe cooled down. So when the universe cool down, the proton and electron can bound together, and like this is when the atoms form. Why we know this happened? Just like your TV screen, if you have inside is very hot and outside is is very cold, then you will see a TV screen from the plasma. And this is exactly what we have like observed. So this, like the TV screen from the Big Bang, is what we call the cosmic microwave background. So inside the cosmic microwave background is the plasma, and outside is the atoms. And since we discovered that in the 1960s, of course we have flown many like satellite to observe the Big Bang. Like just like at home you change your TV every 10 years. We like astronomer also change like our satellite every 10 years. So you can see that the first satellite that we flown is called Kobe in the 1990s. And then in 2000, we flown like another one called like the Gmac. And then in 2010, we have a Planck. And also just like your TV at home, each time you upgrade your TV, the resolution become better and better. And through this, like the TV screen from the Big Bang, we can start to understand what happened to the Big Bang. So this is like one of the strongest clue why the Big Bang has happened, because once we see this screen, we know that the universe has to be extremely small in the past in order to be extremely hot. So this is the first few 1,000 years of the universe. So after the cosmic microwave background, of course, the atoms form, and for this like first 0.1 a billion years, or the first 100 like a million years, the universe is quite empty. So we have only the atoms in the form of the hydrogen and helium, because these are the most simple atoms that we have. But luckily, because of gravity, these like atoms will start to collapse. Like this gas will start to collapse and form star. And one way you can think about this is that if you think about the universe is like a country, then at first this like country is pretty like empty until the first like a settler on to the country, right? So think about the star is like the first like person that live in the country. So after the first like star form, they're just like people. Once you have people in the country, you will start to change the landscape. So what happened is that after the star form, of course, the star will start to irradiate. It shines, and at its shines, it starts to put out some energies, and this energy will in turn try to break apart the proton and electron, meaning that the universe come from a plasma state, go to atoms, and then after the star form, the atoms go back into plasma. So even though most of the thing that we see on Earth now is in the atoms form, but outside Earth and galaxy, most of the gas in the universe is actually just a plasma. It's a very, very hot like plasma. And this like simulation showing you what happened to this first 100 million years. So after the star form, the starlight start to percolate into the gas and try to reionize the gas. So the gas go from ion, become atoms, and go back become ion. So this is what we call reionization. So why do I spend like so much time to talk about reionization? Because this will go back to this like big tension and dilemma the James Webb found. So anyway, so after the first star form, and by the way, the study of reionization is also a very hot topic in astronomy. You can observe this reionization like processes with your with a radio dishes, but you need a very big one. So in Australia and also in South Africa, we are building an array of radio dishes with about a square kilometer array. So this is called the square kilometer array, or SKA. Just like you have many small like astro like dishes, and then you put them into a square a kilometer array. Then you can start to look at this process of the reionization. So this is the first 100 million years after the first star form. After the first star form, what happened is the galaxy formed, right? So just like a country, once you have more and more people, the people become a city. So a galaxy, what we call a galaxy, is just a community of stars. So when you have more and more stars get together, then we form a galaxy. And we believe that the first galaxy formed around first billion years, and over the next 12 like billion years, the galaxy will continue to evolve to form what we see like today. So if you look at the galaxy that we live in, what we call the Milky Way, is one of the many like a galaxy in the universe. It's just like Malaysia, right? So if you form a city, you have many like city. You have like KK, you have Kuala Lumpur, you have Malacca, and so forth. And all these like city, of course, host star. Sun is one of the star, and the Earth is one of the planet, and the story goes on. So one of the key topic in astronomy is try to understand what happened to the galaxy, right? So during this whole period from 1 billion years to like a 13 like billion years, what have happened to the galaxies? How the galaxy grow over time, just like how you come from nothing in Borneo Island and more like people live there. And this is also what we want to like study, what we want to like discuss in this coming like conference. We want to connect what we call the near and the far. So what do we mean by the near and the far? That there are two ways to study how the galaxy like evolve. So one is the near, which is looking at like our own galaxy, like the Milky Way. So looking at the Milky Way is really like helpful, despite the fact that we have many like galaxy. Of course, most of the galaxy will only look like a dot on the sky. But for the Milky Way, is the only like galaxy that we can study in great like details. So a lot of like action has been going on in the study of the Milky Way in the last few years. Like you might have heard of the satellite that the European has flown, I think in 2015. So the Gaia satellite. So this is a satellite that try to monitor the motion of a billion stars in the Milky Way and try to understand the evolution of the Milky Way. We love the Milky Way a lot because, again, like you can study in details what happens to the galaxy. Just like if you live in KK, you understand like KK much like better. So you can use the historical like artifact of the city to get a sense of what has happened to the city. But just like like real life like archaeology, if you look at the historical like artifact, you can only go back so far, right? So maybe if you look at the Malacca site, you might understand the history up to 1400, like 1300. But if you want to go back in time, that become more and more difficult because most of this like relic would have also been like destroyed in the galaxy. So this is why, even though like the Milky Way is very exciting, it does not really like answer the first few like billion years. So what we call the early galaxy evolution. And in this part is where the space like a telescope become quite important, like especially for James Webb. Like to understand why James Webb is so important for this, like Emma like mentioned that like James Webb is a infrared like telescope, and this played a big role. So what happens is the following. So if I want to find a very far like galaxy, one way to look at this is to look for the radius like galaxy. Why this is the case? Because if a galaxy is really far, the light will take a long time to reach us. But at the same time, like we also know that the universe is expanding. So as the universe expands, the light gets stretches. Right? So the wavelength of the light go from like a short wavelength become longer wavelength. Or put it differently, if you have a galaxy that is in the visible light, and this galaxy is really far from you, then this like galaxy will appear to be in the infrared because the expansion of the universe stretches the light. And this turned out to be extremely like useful, meaning that if I look at the galaxy, if it looks more blue, most likely it's a galaxy that is like very nearby. If a galaxy is like a really red, this is a galaxy that is like really far away. And looking for far away like galaxy is a way to look for the oldest like galaxy. And the logic is the following: because if a galaxy, let's say, is like 10 billion light year from you, then the light of the galaxy will take 10 billion years to get to you. Meaning that the picture that you're taking now is a photo of the galaxy 10 billion years ago, because it takes 10 billion years to reach you. Or like if you put all this together, meaning that if I can find a galaxy that is shining in the infrared, but not showing up in the optical, this might most likely will be the oldest like galaxy that we know in the universe. So this is why like James Webb is very important, because the Hubble Space like telescope is observing in the optical and the UV light, but the James Webb is looking at the infrared. Because you're looking at the infrared, you can further push the timeline to look for the oldest like galaxy. And besides, the wavelength is really important. As you can imagine, if I have an object that is 10 billion light year away, it would be extremely faint. And this is why we need a very big like telescope. By the way, this is also why, in order to find this oldest like galaxy, you cannot just look from the ground, right? So like you cannot just look from Sabah. So one of the reasons that you cannot look from Sabah is because the Earth like atmosphere will block many of the light. So here is showing you what type of molecule of the atmosphere is blocking what light. So like most of the optical light goes through, and this is why we can see the optical light. But the water, like a vapor, and also the ozone, like a layer on the Earth, block most of the UV light and the infrared, which is good for us. It blocks the UV light, but also means that if you want to look for the oldest like galaxy that shine in the infrared, you cannot see that on the ground. And this is why like James Webb is put into the space. And the other reason that James Webb is really important is the aperture, so how big the telescope is. So if you look at the oldest like space or telescope, even for the Hubble Space like a telescope, the famous one, it's actually pretty small. So you think about the Hubble Space telescope is about 2.4 like a meter in diameter, so it's not like longer than 1.5 per a person. But on the ground, we can build much larger like telescopes. So in the past, in the space, it's really hard to look for very faint like object, because the bigger like telescope you have, the faster you can collect the light. But what has changed, of course, James Webb is extremely big, and this is why we built a huge like telescope in the infrared in order to find this oldest galaxy. And the way that you look for the oldest like galaxy is actually quite simple. This is what we call where is the Wally game. So this is the same patch of the sky observed on the right by Hubble and on the left by James Webb. And you can see a few things here. One is that the James Webb image, of course, is much sharper than the Hubble, because it's a very big telescope, and therefore you can like collect light more effectively. But more interestingly, you can also see that there are lots of things that are in the James Webb, but actually not in the Hubble. So these are exactly the galaxy that is extremely rare, and therefore are extremely ancient. So this is the way that we look for the oldest like galaxy in the universe. Of course, like astronomers like do not just go back and forth. So we write algorithm to look for this red like galaxy. So you might already like spotted a few. A famous one is this one. So you can see that like there's a red like galaxy here, but then but you don't see that in Hubble, right? So this means that these galaxies are mostly to be quite red, and therefore to be quite old. And what have we found? So like this is sort of the discovery plot. So here, what is shown here are some of the oldest like galaxy that we have found before James Webb. So the white point here show what we have found with the Hubble Space Telescope. The axis here show you the redshift, meaning that how red the galaxy is, or in more human term is the one on the top. So we are looking at the time since the Big Bang. So the oldest like galaxy that we know is called GNZ 11. So this is a galaxy that formed just after 400 million years after the Big Bang. But this is like after Hubble has searched for about 30 years. Guess what happened when James Webb first launched? So within 2 weeks, this is where we are at. So within the first 2 weeks of like James Webb, we find a lot more oldest like galaxy that we know. Of course, like this is not surprising in a way, because like this is how we designed the James Webb to do that. In fact, the oldest like galaxy that we found is now about 300 million years. And you might think this is good, right? But this is exactly where the dilemma comes from. So it's like, yeah, we expect to find some old galaxy, but not really that many of them, right? So think about if you go back in 2000, like like BC in Borneo, like island, and then you see, a pyramid. Then you're like, how does the pyramid come to place, right? Where, like, how do you build the pyramid so early on? So this is exactly the same like dilemma that we face, because we believe we know how the galaxy form. We know that it will form a few of them, but not that many of them. And the reason that we know that it cannot be that many of them come back to the first part, right? So when you form star and galaxy, it will fundamentally change the landscape, because the star will shine, and as it shines, it will like reionize the gas. And we have some good understanding on how much the gas has been reionized. And this seems to be in tension with how many like galaxy we found. It's like you find a pyramid, but the pyramid do nothing to the surrounding, right? So it's like really, really strange. So this is quite exciting in a time that, like this is what we talk about. Even within the first few months, it start to challenge like our understanding of astronomy. We change like how to challenge like our understanding of like, do we understand how the galaxy like evolve? Used to be, one like suggestion is that maybe all these like discovery are not real, because it's the first few weeks of James Webb. We still haven't understand the machine quite well. We haven't calibrate the light quite well. But even as of this month, like last month, actually, this is in December 2015, like in 2022. So not more than like a month ago. In the last few weeks, still, if you read some of the paper in astronomy, there are more and more proof to show that this galaxy, the oldest like galaxy, we do found a pyramid at 300 like a million years after the Big Bang. How they form, we do not know, but there's a big like galaxy formed very soon like, after the Big Bang. And this is sort of the excitement, right? So each time you have a new telescope, you fundamentally change how we understand things. And like James Webb has really started to challenge that. So this is sort of the excitement about the oldest like galaxy, but I do not want to leave you with just like believing like James Webb is only looking at the galaxy. So one of the exciting thing about James Webb is to look for aliens, right? So like look for life outside the solar like system. Of course, we will not see the alien like themselves, but one way to see if there is life outside the solar like system is looking at the atmosphere of the planet outside the solar like system. So to look at if the planet contain like water or the organic like a molecule. And also like this type of like molecule, like waters and all this like organic like molecule, they only shine in the infrared. This is also like why we put James Webb into the space, because the infrared light is very important in characterizing if a planet contains water or the other organic like a molecule. So this is also a spectrum from James Webb. So this spectrum is just a rainbow of light from the planet. And this data show that for this planet, it does contain water. And amazingly, I think like James Webb only spent like tens of like a minute to look at this like planet, and immediately you can confirm that these planets do contain water. But this planet certainly like do not have like aliens, because this planet is too close to the star, and therefore like couldn't have supported life. So this is one thing that James Webb can do. The other thing that James Webb can do is improving the resolution. So when you go out like later to look at the telescope, the resolution that you would get is not great, because on the Earth, the light is being scattered by the atmosphere, especially in a tropical like country in Malaysia. There are lots of cloud. The cloud will scatter the light. So if you look into the ground, most of the things that will seem quite blur. So, and which is what is shown on the top here. The Hubble Space Telescope is sharper, but of course it's limited by how big the telescope is. So how sharp the image is also depends on how big the telescope is. James Webb being in the space and also is extremely large means that the image will be extremely, extremely clear. And to show you some of the comparisons, on the left here is what you can observe on the ground. On the right-hand side is what you can see with James Webb. And not even comparing to the ground, even you compare to the older space like telescope, like the Spitzer, which is launched like around the same time with the Hubble. On the left is what we had before. On the right is what we have now. Certainly, it's very like pretty, but also like this type of like resolution is also how we understand all the astro or physical like processes that is ongoing in the galaxy. Finally, you can look at the left-hand side. What we have is with this Spitzer, and on the right, what we see in James Webb. As you increase the resolution, you can also start to discern some of this interstellar medium like between stars. So this is a very quick introduction about James Webb. I hope that today give you some excitement about what James Webb has delivered in the first few months. If you want to know more, just stay tuned. We will have more talks for you. I will stop here and take questions. Hello.
Okay, I'm here. All right. Thank you, Prof. Madia Yuansen. So imagine the James Webb Telescope can see 300 million years of galaxy, 300 million years age of galaxy.
Yeah. So
After
the
Big Bang, after Big Bang.
Yeah.
Right. So bayangkan lepas Big Bang 300 juta tahun selepas Big Bang, itu adalah galaksi yang paling jauh yang pernah nampak menggunakan James Webb Space Telescope. So macam kita yang tengok ni, macam tadi ada satu astronomer ni yang dalam bilik ni, nanti kita kenalkan dia. Dia cakap bintang paling dekat matahari, of course 8 minit kan. Bintang paling dekat selepas matahari adalah Alpha Centauri. Dia ambil masa 4 tahun cahaya. Kalau kita gerak dalam masa cahaya, gerak dalam kelajuan cahaya dari sini ke sana. So ni 300 million selepas Big Bang. How far it is from? Do we know how far it is from the Earth?
So it's 13 minus 13.8 minus 300, right? So because the universe is like 13.8 like billion years. So this galaxy is about 13.5 billion light year away from us, roughly.
Wow. Bayangkan jarak galaksi yang dia tengok tu 13.5 bilion tahun untuk sampai ke galaksi tu kalau kita gerak dalam kelajuan cahaya. That telescope is super powerful. Okay. Jadi kita bukakan sesi soalan kepada pengunjung yang berada di sini dan secara online. Siapa-siapa yang ada soalan boleh bertanya. Okey, ada soalan. Baik. Ada soalan dari online daripada Christine Yan. Berapa jauh James Webb Space Telescope travel sekarang dari bumi dan berapa jauh dia boleh pergi?
So James Webb is part what we call the L2 point. So it's not like a satellite that go further and further away. So it's actually parked in a fixed spot. The fixed spot tend to be like gravitationally stable. So most of the expensive satellite is parked in this spot where you are balancing the gravity from the sun, the moon, and the earth. So this is the point where you get quite close. Actually, I do not know how far is L2 point, but I can Google it quite quickly. So it's parked somewhere around 1.5 million kilometer away from us.
So it's like one level, that level only. Okay, we have another question. From Haris Azman, Facebook of Tarikh Malaysia. What is expected output from James Webb Space Telescope for the upcoming 10 years from now?
Like no one knows. So this is the thing, right? So we have planned for a lot of science for James Webb. So after all, this thing costs 10 billion like dollar. So you do not want to spend 10 billion like dollar like without like knowing what you do. So the James Webb, we spent about 20 years to design and plan about the science. So there are a few key science cases. So I show you two of them. One is looking for the oldest like galaxy. It overachieved, right? So you get more than what we found. That the other is to look for the planet like atmosphere. But there are also the other science that we want to understand, like including how the black hole form and so forth. But it's really hard to know what happened in the next 10 years, right? So when the Hubble Space Telescope first being proposed, it does not do the science that we are like doing now, right? So we know it is really like powerful, but it's really up to the like the scientists to come up with like innovative way to do that. As you might not know, like today is also the deadline for the James Webb like proposal. So most people can apply for time from James Webb. The important point here is that you need to have a good like proposal. It's highly like competitive. I think now the over subscription rate last year I think it's like 20-1, meaning that is it 20? Yeah, like roughly that, meaning that you write like 20 proposal, like one of them like will be selected. So what you can do in 10 years, like no one know. It depends on how like innovative you are. But certainly, I think the key science goal will happen, including finding the oldest like galaxy and characterizing the atmosphere of the planet outside the solar like system.
We have another question on James Webb from Muhammad Ahyan. How people on Earth make sure James Webb safe from asteroid or destroyed by asteroid? Like we heard that one of the mirror was crashed by a rock from the space. So
Right.
yeah. So why can you comment on that?
Right. So it's something that we of course need to take into account, because that you do not want to float into the space and then like hit by the asteroid and then it's done. The chance that it hit by a big one is quite like minor, but even is continuously being showered by a small asteroid, and this is bad enough because the James Webb is not like one big mirror; it's like many small mirror. If you see, it's a hexagon, so it's also you need to calibrate the mirror so that they can coordinate the light. And imagine how accurate you need to do that. There's about micron like meters. So you need to actually try to calibrate the mirror exactly to like a split hair like differences. And the asteroid will keep like hitting it. It will scratches it a little bit. More importantly, it will tilt it. But so it's very funny. In James Webb, we call them a major tilt event if the mirror move by like 1 micron like meters. But luckily, we have all the instrument to recalibrate that, right? You know how much is being like shifted, and then you try to move that a little bit back. The chances that you be like hit by a big one, like again, the space is extremely vast. So the chances is not completely impossible, but the chances that it hit by a big one is like unlikely. It's just like the Earth like hit by a big one is unlikely.
Alright, any question from the floor? Ada soalan lagi dari pengunjung sini? Okay. Okay, from online pun tiada. There's no more questions from the online. So we thank you so much, Prof. Madya Yuan Senting. Thank you so. Let's give him a big applause to Professor Madya Yuan Senting. And thank you. And please take care of yourself. You know you had COVID. Take care of yourself, and we pray for your healthy. Get well soon.
Thank you.
All right.
Bye-bye.
Thank you.
Bye.
Bye. Ya. Okey, jap, kita update dengan weather dulu. Weather forecast mengatakan bahawa gerimis. Okey. Tak apa, jangan risau. Kami akan tetap buka teleskop tapi bukan di atas. Kita akan buka di sebelah sini ya. Okey, kita ada plan B. Kalau tak tengok langit di atas, kita tengok langit di skrin. Okey, kita bawa langit sini lah kan. Bolehlah betul kan. Alright. Kalau boleh minta bahagian teknikal sharekan skrin boleh? Jumpa masuk. Okey, kita jalan-jalan lah dalam bawah bumbung ni. Untuk pengetahuan semua, saya sekali lagi ingin menjemput semualah untuk scan QR code untuk dapatkan sijil. Anak-anak pun boleh dapat sijil, letak je nama. Yang saya nampak ada satu stargazer paling muda. Itu dia. Hai, comel. Observer paling muda malam ini. Okey. Letak, jangan lupa dia pun bagi sijil lah. Okey, saya bagi sijil kat dia. Okey. Boleh off lampu depan ke? Depan sini. Okey. Tak payah tengok saya, tengok saja sini di skrin. Yang penting skrin bukan saya. Okey, pada malam ini actually kami punya plan untuk tengok bulan. Okey, bulan dan objek-objek lain lah. Jadi apa yang kita boleh nampak pada malam ini? Silap lagi. Okey, ini adalah satu software. Ini bukan kamera. Ini adalah satu software dinamakan Stellarium. Yang bestnya dia adalah free. Boleh di-install, tapi saya pasti kalau iOS. Kalau phone iOS ni orang mahal, orang kaya. Jadi masa berbayar ke kalau yang iOS? Kalau di Android free kan? Ada yang free version. Okey. Stellarium, Stellarium. Okey. So ini adalah simulasi langit. Okey. Simulasi langit maksudnya kita boleh tengoklah apa yang kita mahu tengok pada waktu malam ke siang ke pun boleh. Tak kisahlah, pedulilah malam ke siang ke di mana sahaja kita berada. Di bumi, di mari. Okey, jadi ini adalah di KK. Saya macam mau tak depan, tak nampak apa ni. Ya? Di sinilah. Tak nampak ni skrin, tak nampak skrin. Okay. Okey. So ini adalah langit malam sekarang di KK sekarang kalau tak hujan. Malangnya ada awan daripada Telupit sampai Ranau sampai sini. Kami ni bukan ahli nujum kami bukan juga meteorologi, tapi kami tengok guna satellite. Ada kamu tengok je windy.com. Windy memang digunakan untuk stargazer tengok langit. Kalau awan tak awan. Okey. So ya, STELLARIUM bukan nak promote untuk beli tapi ini free. Yang bestnya boleh pakai untuk laptop dan juga kalau ada cikgu-cikgu sini, dia boleh juga pakai untuk website. Dia ada sedia dalam website. Jadi tak payah nak install. Itu yang best. Okey, apa yang kita boleh nampak ini malam? Ada nampak tak benda yang apa? Bentuk yang paling senang kita tengok. Ada 3 bintang lurus. Yang paling famous ni? Mana? Tu 3 ni. 3 ni. Yang bestnya 3 ni. 3 ni. Laser. Mana laser? Biarlah tu. Pakai mouse juga. Okey. 3 ni adalah actually belt of Orion. Orion's belt. Atau dalam bahasa Melayunya, dalam silibus Melayu, belantik. Belantik. Bush belantik Orion. Jadi yang bestnya juga, sebabkan sekarang ni di atas kepala, untuk yang beragama Islam kami menggunakan di Malaysia, di Malaysia, beragama Islam di Malaysia sahaja, bukan di tempat lain. Jangan pergi Kanada kau pakai ini. Okey, ini di Malaysia kita boleh pakai buruj ni untuk melihat arah kiblat. Arah kiblat kita kalau di sini 290 hingga 291, lebih kurang dengan arah bintang 3 ni. Tapi macam mana, mau tengok ke kiri kah, ke kanan kah? Macam mana? Jadi kita tengok dari satu bintang yang cerah dinamakan Sirius. Seriously serious nama dia bintang. Nama dia Sirius. Okay. So dari Sirius, maka arah kiblat ni dari mulanya dari sini. Yang ni ke sana. Bila kita tengok sana kan? Nampak tu. Northwest. Sini west, barat. Ni northwest. Ini barat 270 darjah. Dia hampir dengan northwest. Lebih kurang tambah lagi 45 darjah. Okey, so ini adalah arah kiblat. Pergilah mana-mana, mau pergi Maragang ke, mau pergi di JB ke, mau pergi Perlis, Langkawi, shopping-shopping Langkawi ke apa kan? Mau pakai Orion boleh. Tapi juga yang bestnya juga bukan cakap arah kiblat, arah utara, selatan, timur, barat pun boleh. Macam mana mau tengok? Dari sini, kan tadi kita tahu, dari Sirius pergi sini, mahala ke barat. Sirius akan berada di belah timur. Sana barat, sini timur, mana utara. Tengok yang dia punya bawah belt dia, ada 3 bintang lagi, lurus. Ya ini, 1, 2, 3. Ini dia punya pedang. Yang ini mahala ke selatan, yang ini mahala ke utara. Tapi pakainya waktu bila? Ini boleh pakai bila-bila. Ini tak kisah. Mau pergi pakai Canada kan boleh juga. Okey. Mau pergi mana lagi? Mau pergi New Zealand, Australia, boleh pakai. Jangan pakai arah kiblat, pakai ini ya. Pakai utara, selatan, timur, barat boleh. Okey? Itu tak kacau. Alright. So, kita nak tengok bulan. Mana bulan? Adik-adik, mana bulan, dik? Mana? Atas. Atas Mars. Mana Mars? Sebenarnya kita nampak ada 2. Ada berapa planet? Cuba kira ada berapa planet situ? Ada Mars lagi. Ni planet ke bintang? Bintang. Ini? Bintang. Ini? Ni? Bintang. Ni? Bintang. Ini? Kenapa bintang? Alamak. Stuck. Okey, ni? Planet. Jangan ada cikgu belakang kau tu. Dia pandang siap kau tu. Okey, ini planet. Planet Jupiter adalah planet yang terbesar dalam sistem suria. Bahasa Melayunya adalah Zuhal. Mana ada Zuhal? Salahlah, Mustari. Kamu ragu kena juga ni. Cikgu mana tu cikgu? Kamu orang buka balik buku. Okay. So Mushtari. Okay, Mushtari, our big talker. Okay. Our big brother. Okay. Then Mare, planet merah. Kita boleh nampak kalau boleh nampak kalau tak ada awan. Boleh guna teleskop boleh nampak tau. Okay. Jadi malam ni yang cantiknya ada Jupiter, ada Mare. Dan tadi petang kita tengok balik kita menggunakan kuasa stellarium untuk patah balik masa. Terang sangat ni. Matahari baru mau terbenam. Belum lagi maghrib. Nampak? Tadi 2 ni sekarang? Kali 2. Kali 2 kah? Cuba kira. Ni mana ini planet ke ni? Ini? Asyik baik. Okey, ni planet. 4 planet dalam satu barisan. Selepas matahari terbenam. Kalau malam ni terdapat, esok lagi ada kan? InsyaAllah kalau kita hidup lagi. Ada lagi yang boleh nampak daripada ni. Ini saya kasih pusing balik ni. Atas, utara, bawah, selatan. Okey. Matahari terbenam sini. Nampak Saturn. Saturn planet bahasa Melayu apa? Zu lagi. Zuhal. Planet yang bergelang. Lepas tu Venus. Zu lagi. Zuhrah, bukan Zurah. Okey, Jupiter, Mushtari, bulan dan Mare. Okey, satu jajaran. Esok pula menggunakan kuasa stellarium saya akan menambah satu lagi hari. Nampak tak apa bezanya? Nampak tak? Apa yang beza? Kedudukan bulan. Kedudukan bulan akan makin lewat. Maksudnya dia ke belakang. Makin lewat maksudnya dia akan lewat terbenam. Bulan pun terbenam? Ada soalan. Tapi tak bawa hadiah lah. Prof? Doktor? Bagi hadiah stiker kan? Okey. Soalan dia berbunyi. Cikgu belakang dia nampak. Berbunyi, adakah bulan, manakah arah bulan terbit? Kalau dia ada terbenam, mesti terbit kan? Dari arah mana? Okey, kita tahu matahari terbit dari arah timur, terbenam di arah barat. Bulan barat. Terbit barat, terbenam timur. Terbaliklah. Maka hancurlah dunia kita ni. Mau kiamat sudah. Tak dek. Tak dek. Cikgu belakang kau senyum je dek. Okey. Macam matahari juga, dia terbit di arah timur dan terbenam di arah barat. Okey, Mare, Jupiter, Venus, Saturn. 4 planet ni. Ada terbit terbenam kah? Tidak. Cikgu belakang kau gelak lagi ni. Dia macam, aku kena buat kelas ni lepas ni. Maaf, cikgu saya gurau ya. Apa ni? Ada. Apa sahaja objek semula jadi. Okey? Bulan, matahari, planet, dia ada terbit dan terbenam. Terbit di timur, terbenam di barat. Kau Iman, kau ni temberang sekejap kan? Tak, saya kasih tunjuk Saya tunjuk Okey. Saya kasih cepat ni masa. Tengok ni arah utara, selatan, barat, timur. Okey? Semua ni akan bergerak ke arah barat. Maksudnya bila masa berlalu semua akan berarah ke arah barat. Okey? Bintang terbit terbenam? Ada? Tiada. Dia takut tu, dia cakap entahlah. Okey, ada juga. Sama juga saya cakap tadi, apa sahaja yang semula jadi, ada terbit dan terbenam. Dan terbitnya dari timur dan terbenamnya di barat. Okey, saya kasih cepat ni masa. Menggunakan kuasa stellarium, kasih cepat ni masa. Nampak? Terbenam sudah 1 planet. 2 planet. Jupiter pun mau terbenam sudah. Lepas ni masa berlalu. Nampak bulan pun terbenam di bahagian barat. Mari pun sama juga. Bintang-bintang ni pun sama juga. Okey? Kenapa? Mengapa yang berlaku begitu? Apa yang terjadi? Adakah mereka bergerak atau kita yang bergerak? Siapa yang bergerak? Salah siapa? Bumi yang bersalah. Bumi yang bersalah. Sebab bumi ada dua pergerakan bumi kan? Bumi berputar dan mengorbit. Kan? So ini pergerakan, ni adalah bukti bumi berputar dari arah barat. Dia diam saja. Barat ke timur, terbalik. Okey, bila dia terbalik, kita punya nampak terbalik. Okey? Apa tak nampak ni? Matahari naik belah timur, bulan pun naik belah timur. Kejap. Kenapa? Kenapa ada bulan waktu siang? Nampak bulan ni? Ada matahari ni, ada bulan juga. Ini kita panggil daytime moon. Okey, bulan waktu siang. Ya, daytime moon. Kenapa? Sebab bulan juga ada fasa. Dia ada fasa. Betul kan? Kita tahu bulan ada fasa. Kan? Tapi kita tahu waktu bulan, kita nampak bulan waktu bulan penuh saja. Yang malam tu kita nampak. Tapi waktu fasa lain, takkanlah separuh malam siap dia betul hilang. Kemanakah dia pergi? Macam tadilah. Sekarang ni bulan yang sekarang ni kalau kita tengok bulan kan menggunakan teleskop, kasih dekat dia. Mau tengok bulan guna teleskop tak? Mau kah? Ni contoh ni simulasi. Kita pergi bulan. Bulan hampir separa. Okey. Bulan sekarang 0.1. Umur bulan ada kat sini nampak dia. Dia lebih kurang separuh lah ni. Dia belum lagi separuh belum lagi fasa separa. Okey. So bulan waktu separa. Kita tahu kalau bulan penuh 12 jam dia waktu malam. Kalau bulan separa berapa jam waktu malam? Separuh lah. 6 jam lah. 6 jam malam. Lagi 6 jam tu waktu bila? Waktu siang. Sebab sudah 6 jam malam, mesti 6 jam siang. Okey? Alright. So ini adalah bulan kalau kita zoom in lah. Nampaklah kawah-kawah dia ni. Okey. Ada moon. Okey. Alright. Lagi saya mau tunjuk. Mau tengok marikh menggunakan teleskop. Kita bayanglah kita tengok teleskop ni kan. Mau tengok teleskop tak? Mau. Okay, let's go. Mars. Nampak bergegar dia tu. Atmospheric ni. Atmosphere ni. Okay, nampak tak marikh ni? Okay, nampak tak marikh ni dia macam dia ada topi. Macam burger. Macam burger. Ini panggil ice cap. Dia ada snow. Snow. Tapi Dik, kau jangan pergi sana kau Dik. Kau ingat tu sejuk memanglah sejuk tapi bukannya snow macam kita. Boleh main air, baling-baling kan. Kau pegang sakit kau tangan tu. Okay? Nanti tanya dengan astronomer. Ada astronomer sini tau. Ada 3 orang sini astronomer. Nanti cari. Ada ni kat sini 3 orang. Ada. Okey, ada. Ada. Kalau nanti tanya astronomer. Kenapa ni ice cap tak boleh sakit kalau pegang? Okey. Di marikh dia 2 kali romantik daripada bumi. Kenapa dia romantik? Sebabkan dia ada 2 bulan. 2 bulan ini. Satu Phobos, satu lagi Deimos. Nama bulan kita apa? Siapa tahu nama bulan kita? Moon. No, nama bulan kita Luna. Macam, tahu ke tengok Sailor Moon? Yang nama kucing dia tu Luna. Nama kucing Luna. Tengok Sailor Moon nanti balik. Okay? Alright. Apa yang lagi best? Apa lagi ya? Mau tunjuk? Okey. Mau tunjuk satu, dua, tiga. Tiga. Tahun ni 3 musim meteor yang best. Mau tengok meteor kah? Siapa sini pernah join kami tengok meteor shower? Kamu orang ni rugi tau. Kami kan pada tahun 2018 di Tegudon Tourism Village, Kota Belud, satu malam tu kami tak tidur. Kami pecah rekod Malaysia tengok meteor paling banyak. Satu malam tu kami menjerit sebanyak 1,243 meteor. Mau join lagi kah? Tahun ni best tiga musim. Bulan April, bulan 8 Persit dan bulan 12 Geminids. The best is Geminids lah. Tapi Lyrics. Bulan 4 Lyrics, bulan 8 Persit, bulan 12 Geminids. Bulan 4 dia best sebab kami tu besar-besar. Panjang-panjang. Bulan 4 ni best tapi kita kena beraya lah di bawah meteor sebab dia malam raya. Jadi kami pun macam fikir juga mau buat event ke beraya sama-sama kita ni ya. Okey, tapi balik raya nanti mungkin kurang like pollution lah kan. Jadi bolehlah kita tengok sama beliau-beliau, anak-anak, cucu-cucu kan. Tengoklah meteor shower. Okey, bila pada bulan 4 saya kasih jawapan bocor pun ni. Nampak tu. Lyrics. Okay. April Lyrics. One of the biggest meteor shower lah. Dia punya meteor memang besar-besar. Best. Panjang warna hijau. Oh hijau tahu. Okay. Adik, orang lain dek. Cikgu belakang kau tengok dek. Takut sudah ada. Aurora, kita kat Malaysia boleh nampak Aurora tak? Boleh kan nampak? Tak kan? Siapa dari kudat hari tu dapat tahu viral tiba-tiba Aurora? Macam lampu-lampu, tiang lampu begitu kan? Pernah nampak ke di Facebook? Kudat info ke apakah? Kan? Dibilang tu macam tiang lampu. Itu like pollution. Okay? Daripada bagang, daripada bot-bot yang candak sotong ni. Lampu dari situ sebab kan waktu sekarang kan hujan selalu. Jadi kita punya atmosfera sejuk. Bila sejuk dia ada ice crystal. Lepas tu lampu tu punya terang, dia macam terus pergi ke ke langit. So kita nampak lampu yang di langit tu. Okay? Banyak kali lah kami pernah dapat di LD dapat hari tu di Kunak. Tahun 2019 2021 di Kunak. Di Kunak pernah kalau di Semenanjung pun banyak juga di area Langkawi, Perak. So kebanyakan memang banyak di belah laut lah. Okey. Yang bestnya lagi juga, jangan lupa waktu tengok malam raya kita takbir sambil cari meteor. Ada juga ni. Ni apa ini? Apa? Milky Way. Yes, Milky Way. Okay. So ini Milky Way ni kita boleh nampak. Kalau lah. Janganlah kau di KK. Pergilah jauh-jauh sikit. Pergi Maragang. Memang boleh nampak Milky Way. Best. Menggunakan mata kasar. Saya suka ambil gambar. Sebab kan Milky Way ni, yang saya ambil gambar, nampak Milky Way. Contoh gambar ada ke? Sekejap saya cari dulu kalau ada. Gambar Milky Way. Ada ke di luar ni? Mau tengok ke gambar Milky Way macam mana bentuknya? Siapa? Picture. Ni bukan ni dari ni dari Maragang. Ini saya naik Maragang Hill. Ni. Ini Milky Way. Okey, boleh nampak dengan mata kasar, boleh ambil gambar guna phone. Phone pun boleh. Sekarang kan canggih kan kamu orang punya. Mahal-mahal lagi 2-3 ribu. Boleh ambil gambar guna phone, tapi kena edit sikit lah bagi dia terang. Okey, guna DSLR pun boleh. Okey. Kalau mau tengok gambar-gambar Milky Way lagi, esok sila datang pergi ke U-Science, situ ada galeri gambar. Gambar-gambar semua dari Sabah. Dan kita ada juga tim Sabah Chinese High School, plenty out there pun ada juga jual bookmark. Korang mau bawa balik Milky Way, bawa balik Milky Way. Okey. Ni bawah ni mesilah kundasang ni cerah lah. Tapi atas ni ambil kau. Banyak punya bintang. Okey. So nak ambil gambar ni memang kena bertahan sejuk lah. Tahan sejuk, tahan nyamuk. Kalau tak tahan tu, bayarlah kamu fikir ni. Okey, ini saya ambil gambar. Nanti kita ada astronomer, dia ambil gambar Milky Way juga. Tapi dia tak ambil gambar Milky Way macam ni. Dia ambil gambar, dia gunakan radio teleskop. Radio teleskop tu dia menghala ke tengah-tengah Milky Way. Center of Milky Way. Punya banyak bintang kan tak nampak. Ini Scorpius. Okay, ini bintang Antares. Begini. Ini Sagittarius. Okay, punya banyak bintang, susah mau tengok. Ni. Dekat sini center of Milky Way. Okay. Okay, center of Milky Way ni ada apa? Ada apa ni? Siapa tahu? Supermassive black hole. Ada black hole. Dan ada salah seorang dari sini pernah ambil gambar. Itu astronomer kita. Cuba cari. Siapa dia? Carilah. Siapa cari dia dapat hadiah daripada doktor tu lah. Okay. So dia ambil gambar dan dia letak sebagai stiker. Mana stiker tu? Yes. Cuba angkat tunjuk belakang. Stiker tu betul. Itu adalah gambar betul tau. Okay. So gambar saya macam ni, gambar dia macam tu. Siapa yang cantik? Melawan tu, bos. Tak boleh. So itu dalam bentuk radio wavelength. Ni pakai optical lah. Alright, siapa nak tengok? Cari apa? Cari, saya sebut tadi, buruj Scorpius. Ni Scorpius, ini Sagittarius. Emang ni kan macam mana lah kau tengok ni kan? Bintang-bintang ni begini. Bintang ni macam mana? Bintang memang banyak dan hambur betul kan? Macam mana mau tengok dia tu buruj yang kita mau tengok? Menggunakan bentuk. Bentuk. Contoh saya bagi contoh. Ni bentuk 1, 2, 3. Dia bentuk macam Moana punya cangkuk tu. Oh, tahu saya Moana. Ya, inilah. Inilah Moana punya cangkuk tu. Okay? Maui. Kan? Ini mak cangkuk dia ni. Kalau itulah setengah macam dalam cerita Moana kan. It's real, you know. Benda tu ilmu tu ada betul. Ilmu yang dia pakai tu memang diguna pakai. Yang menggunakan bintang untuk berlayar. Okay? Macam tu macam dia kata, tengok bintang ni, dia angkat tangan di laut. Kau ikut jatuh bintang. Memang betul. Itulah cara orang Bajau berlayar dari Filipin ke Sempurna Lahadatu tu pergi ke Semenanjung. Menggunakan bukan GPS. Pakai bintang. Ya, mana ada line? Mau pakai line, dek. Pakai satellite je, dek. Pakai boleh. Okay? So, ini kalau yang kita ada, siapa tahu kita ada berapa banyak buruj yang telah dipakai oleh IAU, International Astronomical Union. Siapa tahu? Ada berapa banyak buruj? Siapa? 4. Biduk, Belantik, Pari, Scorpius. Itu dalam bahasa Melayu. Okay, actually kita ada 88 buruj. Semua kena hafal lah, keluar. Siapa tak hafal, tak boleh keluar. Okay, kita ada 88 buruj yang telah diguna pakai untuk satu dunia. Kalau saya sebutkan kepada orang yang berada di New Zealand ke, siapa yang berada di mana, di Mongolia ke, diorang tahu. Sebab itu memang dipakai untuk satu dunia. Okay? So, itu adalah 88 buruj. Dan actually ilmu buruj ni, nama-nama buruj ni banyaknya daripada bahasa Greek, Yunani. Okey? Dan nama-nama bintang ni apa tu? Rigil, Centaurus, Hadar. Ini banyak nama bintang ni daripada bahasa Arab. Al-Hadar nama patutnya. Al-Hadar, Rigil. Rigil ni apa bahasa Arab sebenarnya? Okey? Apa tu? Antares. Antares, Alte. Kan? Bunyi Arab. Ada al. Kebanyakan bintang namanya daripada bahasa Arab dan burusnya asal 88 burus ni dipakai ni bahasa daripada Greek. Okey? So ini kita akan belajar tentang Greek punya ilmu, tapi kalau nak tahu kita lagi-lagi di Sabah lah. Orang Bugis kah, orang dusun kah, semua ada burus-burus tersendiri. Okey, contoh macam mana saya tahu? Okey, macam ini kan, tiga bintang. Ini kepala Scorpius. Ini adalah Scorpius. Ekor Scorpius. Nampak macam kalau Scorpius itu adalah seekor kala jengking. Begitu. Okey, macam mana saya tahu? Sebab terbiasa sudah belajar ni begitu. Okey. So saya letakkan, kalau saya letak begini, saya letakkan ni kah? First ni kah? Nampak? Baru nampak kan? Baru nampak dia punya burus dia. Okey, saya letak pula namanya. Okey. Okey, nampak tak? Mana namanya? Tak apa nama pula ini. Okey, nampak tak? Okey, nampak tak keluar nama buruj? Okey, Scorpius, Sagittarius. So nak tahu di mana Milky Way? Cari ekor Scorpius ataupun cari Sagittarius. Okey? So itulah teknik-teknik untuk mencari buruj. Okey? So sila hafal. Okey. Dan gambaran-gambaran ni, kebanyakan gambaran orang Greek Yunani ni, dia suka letak gambar binatang, objek, dan yang ada sana ni ada juga lah modern science punya barang. Okey, macam tahu tak kita ada buruj dolphin. Kita ada buruj dolphin tau. Nanti cari. Okey kalau saya letak gambar kan dia akan jadi begini. Nanti cari dolphin. 1, 2, 3. Mana dolphin? Scorpion. Kalau jengking. Yes, Delphinus. Sebelah kiri tu. Okay, that's Delphinus. Dolphin. Okay, alright. Tu apa dia? Orang Greek punya gambaran kan. Banyak mitos-mitos Greek lah. Alright. Inilah semua. Ni tak semua 88 burus tau. Belum lagi sebab kan kita ada 24 jam. Ni baru 12 jam. Okay. Dah hafal? Dek, dah hafal? Okay. Okay, next. Alright. Okay. Okay. Maka saya rasa saya bagi 5 minit lah untuk sesi soalan sebelum saya habiskan. Ada soalan tak? Ada, kalau tiada saya akan bagi pas kepada astronomer yang ambil gambar black hole. Mau dengar tak dia cakap? Tunjuk black hole, mau tak? Dia nak tunjuk dia punya teleskop live dari Greenland. Mau ke tengok? Mau, okey. Okeylah, kalau tiada soalan saya akan ada dia saya.
How do we join your next activity that are not inside UMS?
Thank you, great question. Okay, you can find us in our Facebook, Twitter, Instagram, not TikTok yet. Dark Sky Malaysia. Find for Dark Sky Malaysia. DARKSKYMALAYSIA. But please come tomorrow. You want to see us again? Please come to see us again tomorrow, so we can give you our proper introduction on Dark Sky Malaysia. Okay. So the next one, I think we're gonna have like comet hunting. Who wants to find comet? Comet ZTF E3 2020. Komet apa ya? Yang viral sekarang ni, komet hijau. Komet hijau boleh nampak dari bumi. 50,000 tahun yang lepas baru sampai bumi. Apa tah? Sorry. Okay. Alright. Next one is comet hunting. Alright. So itu sahaja daripada saya. Emma Zulaiha Zulkifli sign off daripada Askar Malaysia. Thank you so much for listening. So saya nak menjemput our next astronomer. Our next astronomer is Dr. Yuan Senting. Berikan tepukan gemuruh kepada dia. Sorry, Dr. Kevin. Ya Allah, sorry, I was still in Dr. Yuan Sen. Team brother. Alright. Tolong angkat. Hilang lah. Alright, Dr. Kevin Kue kan merupakan salah seorang daripada saintis yang yang discover, gambar black hole. So gambar yang stiker tu adalah salah satu lah. So kita nak tengok teleskop yang dipakai. Boy. Alright. So saya akan paskan the floor kepada Dr. Kevin Kue.
Thank you. Hi, okay. So nanti I tengok. So tadi sudah keluar pergi cek, masih hujan lagi. So tak apa. Kalau sini hujan, kita pergi negara lain tengoklah.
Ya, betul. Sponsor tiket.
Cuk pasport.
Sayang.
Sedia pasport.
Mana pasport? Immigration datang.
Okay, mirror. Okay, tadi Puan Emma dah tunjuk apa Milky Way kan? So kalau you pergi ke Australia, okay, orang asli dekat Australia, the Aboriginal people, mereka akan panggil ini the emu in the sky. So kalau you nampak emu tu, burung tu boleh, you can see that in Australia kan? So for the Aboriginal people, mereka nampak Milky Way yang dia punya dark clouds actually nampak macam emu kan? Ada kepala di sini, dan dia punya leher, body. So kalau you pergi the national park, dia panggil Ku-ring-gai Chase National Park dekat Sydney, dia ada satu rock carving on the ground which looks like the emu in the sky. Okay. Dan sini ada satu round macam telur dia. So mereka buat research kajian, okay, like berapa ribu tahun dahulu. Okay, yang orang asli dekat Australia, the Aboriginal people, mereka guna kalau ni align the Milky Way, the emu on the sky, dia align dengan rock carving itu. That means masa itu adalah masa emu akan bertelur dan mereka akan pergi. Wi-Fi, yes. Oh, StreamYard. How?
I sent to your WhatsApp already.
Oh, WhatsApp.
Let me send to your email.
Okay, so mereka akan tahu bila yang Milky Way dia punya align dengan dia punya rock carving, mereka akan tahu this is the time to go and collect the emu egg, so mereka boleh cari makan. Okay, so anyway, this is just a fun fact, okay? So apa yang saya nak tunjuk ini, this is the teleskop yang kita guna untuk menangkap image lorong hitam. So they are actually made from a few, like almost 9 telescopes. Okay, and the one that I'm working on sekarang yang kita telah baru bina is yang ini, the Greenland Telescope. Okay, so Puan Emma dah tadi suruh bagi tour lah, visit Greenland, visit teleskop ini. Okay, so tak boleh nampak apa-apa, tapi boleh nampak teleskop saja. Okay, so this is the telescope. It's a radio telescope. So dia tak guna mirror, dia tak guna cermin atau lens. Okay, tapi dia guna macam antena. Okay, StreamYard. Then share screen. Okay, so this is the telescope. It's a 12-meter antenna. Okay, and this is all the control room and all the storage space yang kita guna. So this telescope sekarang berada di Tuli Air Base, which is an air base belonging to the US Air Force. So kalau nak pergi sana, kena duduk Air Force plane lah, US Air Force plane to go there. In the future, kita nak move telescope ni ke Summit Station, which is 3,000 meters above sea level, where the atmosphere is much better for observing. Okay, so this is the telescope. This is from the belakang, this is from the depan. Alright, so now this is foto yang saya ambil when I was there. But now nak tengok live image sebab kita ada banyak spy camera dekat situ. Okay, so now kita boleh pergi spy dekat teleskop itu. So first, maybe kita pergi tengok the primary mirror, okay, the dish lah. So internet slow sikit, but internet dekat sana slow, okay, bukan sini. Sebab dia dekat kutub utara kan, internet tak berapa bagus. Telah sejuk. Okay, so this is the dish. Sekarang pukul berapa di sana? 9:30 pagi. Okay, tapi gelap lagi, tahu tak kenapa? Sebab sekarang winter kan in the northern hemisphere, so almost 24 hours darkness, okay? But if you pergi December, memang dulu saya pergi December masa Christmas kan, dia 24 hour darkness. But sekarang you sudah boleh nampak sikit cahaya, okay, in the corner here, okay? But in the afternoon, 1 p.m. pun masih macam ni, okay? Because the sun will never rise, the sun just below the horizon, okay? And you can see this is the dish. Okay, inside here is so all the light from space, they akan bounce dekat sini, then bounce to the secondary mirror sini, then go inside here where we have all the receiver. Okay, so maybe show another view outdoor. Okay, so later kita boleh pilih lah nak tengok kamera mana. Yeah, security spy. Okay. So sorry kena tunggu. Okay, this is different view from the side. Okay, this is from this side. So biasa kita boleh tengok lah kalau ada orang bergerak apa. So kita boleh just in case for safety lah, we don't move the telescope apa. So you tengok sini kita letak hitam punya pixel, tahu tak kenapa? Okay, belakang this is the airstrip, okay, yang the plane akan take off dan landing. So the US Air Force dia takut kita spy mereka, nak kita tahu yang mana plane yang take off, mana plane yang landing. So they ask us to put black pixel so we cannot spy on the military lah, okay? Okay, now we nak look inside maybe the control trailer. Okay, so this is inside. Kalau I pergi sana, if you go there and work, you will work inside here, where you control the telescope. Okay, so this is inside one of the trailer. And this is the main observing computer yang kita guna untuk observe. This is the computer yang engineer dia akan guna to set up all the electronics and all. And then here you also have a backup. So now actually if you want, I can turn on this computer. Okay, I can try. Okay. So especially during COVID kan, we cannot go to Greenland to observe. So kita buat semua remote boleh observe dekat Taiwan or at home lah, you can control. Okay, so you use this remote desktop called AnyDesk. Okay, harap internet okay. Tapi dia lagging sikit, that's why susah. That's why we still need to go there. Because the internet in the north, in Greenland, okay, jangan tengok password. Tutup mic. Okay, betul. Okay, now this is the screen here. Okay, ni dia tak refresh lagi. Okay, so there are 3 screen kan, so you can choose which screen you want to tengok. Okay, tengok sudah buka kan? So now I'm controlling that. Okay, so this is the different screen. So this is yang kita biasa guna punya monitor lah. Dia akan bagi tahu telescope pointing mana. Okay, LST, UT, what is the time. Kita boleh nampak temperature semua. So you nampak sekarang temperature berapa? Negative 23 degrees Celsius. Okay, so this is not the coldest. The coldest when I've been there is about negative 40 degrees Celsius. Okay. So actually kita control telescope macam ni lah. You use command here on the command line. So you nampak like observe this source. Okay. So kalau you panggil observe, that means dia akan point to the source. Saya tak payah manual lah. So computer akan buat everything. So they will point to the source and then dia akan track. Because bumi tadi Puan Emma sudah cakap kan, bumi kita berputar. So everything dia akan move from dari mana? Terbit dari mana? Dari timur ke barat kan. So semua akan ikut. So teleskop kalau kita nak observe, kita pun kena track ikut dia, okay? Actually kalau nak saya boleh bagi command to move, tapi I tak mahu lah because sekarang the engineer cakap about maintenance. You can see banyak failure di sini. Limit something wrong. So mereka tengah buat maintenance, so they have take out some of the thing. Okay, next time lah. Mungkin boleh buat live move the telescope. Okay, so yeah, maybe one more. Maybe tengok this one, receiver cabin. So di belakang, okay, behind this telescope is the receiver cabin. Sini lah. Okay, so when the telescope is pointing up, you can actually climb up. Okay, boleh panjat sini, boleh masuk dalam. There are receiver cabin. That means all the electronics, all the receiver, all is there. Okay, and here. Okay, so this is the receiver behind the cabin. So all the light from space will masuk sini. Then dia akan be record. Dia akan masuk all the electronics. So actually, biasa dia ada 2 rack. I think this rack, yang engineers sudah remove. Mereka nak buat maintenance semua. Boleh nampak lah banyak wire semua. And this receiver, because dia guna superconductor, okay, the temperature needs to be absolute 0. Okay, so outside about minus 20 degrees. But inside here, inside receiver cabin has to be room temperature, about 16 degrees Celsius. Because a lot of the computer, electronics semua, they can only function in room temperature. Kalau below room freezing, dia semua akan rosak. So that's why inside this room, there ada heater to heat up the cabin, so that is about 16 degrees Celsius. But inside here, the superconductor here, they have a vacuum pump to pump out all the air. So their temperature must be absolute 0, okay, minus 273 degrees, okay? So very cold. Okay, so this is the receiver cabin. So that's all I think I want to show. So sorry, cannot move the telescope, but maybe I show like one of the things kita observe dengan this telescope besides black hole. Okay, this is a evolved star. Okay, bintang yang sudah evolve. Okay, near the end of the life, they akan eject all the gas. Okay, out of the star. So this telescope we can study what we call spectral line. Okay, so I think this morning Cik Fatima also showed that you can spread the light into the membiaskan the light kan. Boleh nampak dia punya spectrum. So dalam radio pun kita boleh dapat spectrum. Dan spectrum kita boleh nampak spectral line which is emitted by different chemicals. Okay, spectral line yang kita suka tengok adalah carbon monoxide. Okay, kita nak study molecule, kita study carbon monoxide because it is the second most abundant molecule. Okay, the most abundant molecule is H2, okay, hydrogen molecule, but that one very susah, very difficult to detect. So kita tengok carbon monoxide. Okay, and this is from the Greenland telescope. Kita measure dia punya spectrum lah for carbon monoxide, so we can study the gas and how they move and all these things. Okay, so this is an example of one of the things we can look dengan this telescope. Okay, so yeah, I think that's it. My sharing. So kalau ada soalan ya nanti boleh tanya. Yes.
How you observe black hole?
Okay, how we observe the black hole. So actually, yeah, let me show the slide. This one lah. Okay, because the black hole is very small. Just now Jensen, he mentioned, right, you want to get very sharp images. The more sharp your image, the more detail you can see. So, but the black hole is very small, okay? The size of this black hole is about 0.000000001 degrees. Okay, the moon is about 0.5 degrees. So to get a very sharp image, we actually need a very big telescope. Okay, the bigger the telescope, the sharper the image. And it turns out that we need a telescope the size of the Earth. So, but because we cannot build a telescope this big, right? So what we do is instead we use this technique called interferometry. That means we connect telescopes on different continents all over the world, okay, to join together to form a virtual telescope the size of the Earth. Okay, and then we combine it, all of them observe at the same time, exactly the same time. Then we combine the signal, then we can get this image of the black hole. Yeah. That's all. So thank you very much.
Okey, terima kasih kepada Dr. Kevin Quay, orang black hole, tapi orangnya putih. Okey, terima kasih banyak kepada pengunjung semua. Memandangkan cuaca pun masih lagi hujan, tapi kami sediakan dah teleskop di sebelah dan kita boleh gunakan menggunakan teleskop lah. Tapi bukan tengok bintang lah, kita akan tengok objek-objek bumi, macam bot, kapal. Okey, jadi minta maaf sangat-sangat, jangan risau, langit sentiasa ada insya-Allah. Cuma kita kena sentiasa tengok lah. Okey, so sebelum kita keluar dan melihat menggunakan teleskop, ada orang luar tak? Boleh panggil tak kita buat ambil kasih gambar? Okey, sebelum kita menamatkan sesi pada malam ini, saya ingin menjemput jugalah kepada semua orang. Sila datang esok, kunjungi kami esok kerana esok pun best juga sebab saya pasti ramai yang nak tahu tentang apakah perjalanan kalau kita mau masuk bidang astronomi. Kalau kita mau belajar astronomi, di mana kita mau pergi? Dengan siapa kita rujuk? Kan? Dengan macam mana orang macam Dr. Kevin Quay, Profesor Yuan Senting, orang Malaysia boleh belajar astronomi. Yang sebelum kita dengar Tan Sri Prof Mazlan. Tapi sebenarnya kita ramai lagi. Kalau mau tahu berapa ramai kita ada, sila datang esok. Sebab esok kita akan ada banyak topik tentang kerjaya dan pendidikan dalam astronomi. Yelah, dah belajar astronomi, lepas tu mau jadi apa kan? Jadi ada tak kerjaya, ada tak duit di situ kan? Begitulah. Jadi apakah kerjaya yang kita boleh ceburi kalau kita masuk dalam bidang astronomi? Kerana bidang astronomi saya tahu besar. Dia bukan sejak kita belajar tentang orang yang masuk bidang astronomi ni bukan yang belajar pasal bintang, tapi orang yang buat mirror macam tadi kan, James Webb Telescope. Orang yang buat teleskop, pembuat teleskop, pembuat cermin, pembuat barang-barang untuk interferometry, dia punya bahan-bahan dia kan. Benda tu ada engineers, ada even orang chemistry pun ada juga. So dia tak semestinya dalam bidang astronomi tu hanya untuk orang bintang. Tapi kalau siapa yang macam saya memang suka bintang tapi saya suka buat cermin. Dia punya power dia kat situ. Boleh jemput tak yang di luar? Boleh kita jemput lah, kita panggil semua masuk ambil gambar dulu. Okey, kalau mau tahu lagi tentang kerjaya dan pendidikan, sila datang esok. Jam 9 kita akan adakan satu topik yang menarik daripada kita punya astronomer juga. Jam 9.30 daripada orang Sabah. Ni for me lah, I think saya rasa macam dia seorang saja orang Sabah yang belajar astronomi. Yang betul-betul astronomi, astrofizik ni. Bukan yang macam saya belajar fizik astronomi sampai degree, dia tak ada sampai master. Apa tu? Yang lain tu tiada. Macam dia seorang je orang Sabah, orang Kudat. Jadi sekarang ni dia di UM dan esok dia akan ada untuk sharing macam mana dia dapat inspirasi untuk belajar astronomi ni. Okey? Jadi lepas tu kita pula ada forum antara semua astronomers yang kita jemput dan kita juga ada jemput Jabatan Pendidikan Negeri Sabah untuk terangkan kalau di Sabah apakah perjalanan adik-adik, anak-anak ataupun ada pelajar universiti sini macam mana masuk bidang tu. Nanti dia akan tunjukkan lah. Okay? Sebab saya faham sini ada juga pelajar fizik, even ada pelajar engineers mau masuk bidang astronomi. Mungkin ada space tech ke kan. So kita tanya dengan orang JPN sendiri. Macam mana kalau kita orang kami ni lepas ni mau cari siapa? Kan merujuk sama siapa? Okay? So esok kami bukan di sini tapi di U Science pada jam 9 pagi ya. Ya. Tunggu dulu. Okay? Jadi yang belakang boleh nampak ke tu? Macam gelap je tu. Tengah lah. Ya, sila letakkan nur di muka. Kita juga ada buat siaran langsung untuk semua talk dan forum. Boleh tengoklah siaran langsung kami di Facebook dan YouTube Sky Malaysia, juga Facebook dan YouTube U Science. Okey? Kalau malu-malu mau tanya online pun boleh, tidak masalah. Okey? Maka itu saja untuk siaran langsung. So kita akan akhiri dengan sesi gambaran. Tapi kalau lepas ni katakanlah mau bercakap juga sama astronomer ni kan. Kita ada 3, satu kita punya Dr. Kevin Kueh di sebelah sana. Satu bertapuk sini warna pink. Cik Puan Fatimah. Cik. Dan satu lagi tak ada Afiq tak ada